In this video, I'll explain one of the most important phenomena whose discovery led to exponential development of technology. This phenomena is known as electromagnetic induction, and it's employed in almost any device that runs on electricity. Michael Faraday experimented for 10 years trying to prove that magnet could induce electricity to the conductive wire. He finally succeeded by using two coils of wire winded around the opposite sides of a ring of soft iron. The first coil was attached to a battery, and when the current passes through the coil, the iron ring becomes magnetized. A wire from the second coil was extended to a compass needle a meter away, far enough so that it was not affected directly by any current in the first circuit. When the first circuit was turned on, Faraday observed a momentary deflection of compass needle and its immediate return to original position. When the primary circuit was switched off, the deflection of the compass needle occurred, but in the opposite direction. Building on this observation and other experiments, Faraday showed that the changes in the magnetic field around the first coil were responsible for the inducing current in the secondary coil. An additional inspiration for this video was the challenge I faced in explaining to many of my friends and followers why their ideas and for constructing a wind turbine or water turbines might not work as they imagine. They often expect to produce power according to their fantasies without understanding the complexity involved. I'll use this opportunity to explain that generating electricity isn't just about rotating blades of the turbine. The dimensions and design and the whole approach of concept we'll choose for designing of turbine must fulfill many conditions, and approaches depends on various factors. Anyone who decides to build a wind or water powered generator must consider that the torque needed to move the turbine blades depends on the output resistance and power consumption of the load. For example, if we mount a wind turbine and leave the output as an open circuit without connecting any appliances or battery charger, it would be easy to move the blades at almost any wind speed. The turbine will rotate regardless of its size and power. However, if we connect the inverter and batteries to charge them, and maybe link it to the home grid to power appliances, generator in inner circuit will close, and as we rotate the turbine, it will generate the current, which will create its own magnetic field, which will be opposite on the existing one from the permanent magnets in the generator or dynamo, as we. This opposing magnetic field will act like a brake or resisting the torque of the opposite in the opposite direction. This means we can't use just any size of generators, blades, and any type of construction for any desired power outcome. We must calculate our power needs and use appropriately sized blades, because the torque generated from the wind depends on the wind speed and the surface area of the field in which the blades operate. Additionally, depending on the type of the wind turbine we want to harness, we must choose the right type of blades and overall construction concept. This is ordinary DC motor. This is LED diode. I connect the both wires from the electromotor to the LED diode to demonstrate induction of electric current when I spin the motor. I'm not sure about the lighting, but we'll try. As you can see, as I spin a motor, it generates electricity and LED diode blinks. let's try this with another electromotor. This is another smaller one. Those are DC motors, that means they run on DC current. Let's see this. I'm not sure you can see this, but I will try to make something better. I'll place something to be more obvious. As you can see, for DC motors I must spin faster because their construction is for that. Now next I will try with stepper motors. My name is Zoran Zanda. Thank you for watching, and I promise I will get better and find another interesting topics to talk about, or also you can inspire me with some topic. Thank you for everything. Subscribe and see ya.